Okay, hello everybody. I'm going to try to do this review very quickly since the bell's going to ring and school's going to start in like 15 minutes. So I've got 15 minutes to do this, and I will get it posted as soon as I possibly can. So what we're doing today is just the Unit 8 test review, and there's not very many different types of formulas, but for each formula there's several different questions for it. So in this case, you have the formula x squared minus x minus 2 divided by x cubed minus 4x. And you have to find the x-intercept, the vertical asymptote, removable discontinuity, if there is any, horizontal asymptote, slant or end behavior, and then the y-intercept and domain and range. Okay, so really quickly what we're going to do for this is we are going to factor both the numerator and the denominator and then find the information from our factors. So the x squared minus x minus 2 would be negative and positive here. So 1 times 2 gives you 2, and if you have x minus 2 and x plus 1, then you have your factors, okay? In the denominator, first of all, we can factor out an x, and then we would have x squared minus 4. That's a difference of squares, so it would be plus 2 and x minus 2, okay? So from that, we know that our x-intercepts are going to be from right here. Let me change the color. Okay. So this x plus 1, when we set it equal to 0 and solve for x, that'll give us our x-intercepts. Because we have x minus 2 in both the numerator and the denominator, that's our removable discontinuity. And then our vertical asymptotes will be right there. So let's go ahead and reveal those. So our x-intercept is x minus 1. And our vertical asymptotes are at negative 2 and 0. Our removable discontinuity is going to be at positive 2. And then because we look at our numerator, or our numerator and denominator as exponents to figure out what type of horizontal asymptote there is. And because the numerator is less than the denominator, horizontal asymptote is at y equals 0. Because we have a horizontal asymptote, we do not have a slant or end behavior asymptote. And then for this equation, if I wanted to find my y-intercept, I would plug in 0 for x and solve. And in this case, because my denominator is just going to be 0, I'm not going to have a y-intercept. Okay, and then I look at my, what do I look at? I look at my vertical asymptotes and my removable discontinuity, these two things to figure out the domain, and then I can look at the graph to figure out the range. So for the domain, because I have a negative 2 here, then it's going to be from negative infinity to negative 2, and then the break because of that, and then 0 is your next number. Whoops. Right here. Why is it not writing like I want it to write? All right. And then so 0, and then 2 is your last number, okay? So you just have to plug in all your vertical asymptotes and removable discontinuity. Now let's look at the range really quickly. Notice our range says from negative infinity to 0 and 0 to positive infinity. Well, the reason why is because we don't have any x-intercepts. Hold on, let me look. Let me look at this. Yeah. Why is it from 0? That is really weird. That one should be from negative infinity to positive infinity. On the range questions, really look at the graph first. The reason why there's one bell. I still have a few minutes. The reason why I want to dispute this range is because you have an x-intercept there, so y can equal 0. But just look at your graph, look at your table, and see what's up with that. I don't believe there's any weird graphs on the test. If there is, and you don't agree with the answers, just let me know that you think there's something up. Okay, here's another example. With this one, you would want to factor out the 3 in the numerator, and gives you x squared plus 3x minus 4. Okay, so you would have two numbers that multiply together to get 4 and add or subtract together to get positive 3. Well, that tells me 4 and a 1. And then in the denominator, again, we can factor out the 2. We get x squared plus 4x plus 3. Let's see, 4x, no, yeah, 4x plus 3. So we're going to have two pluses there because everything's positive, and it's going to be 3 and 1. Okay? Now notice, because we have different signs here and here, we are not going to have removable discontinuity. Okay? In this case, our x-intercepts would be -4 and +1, vertical asymptotes -3 and -1. No removable discontinuity. Because my degrees are equal to each other up here, I'm going to take my my leading coefficients to find my horizontal asymptote. And so the horizontal asymptote is just at 3/2 or 1.5. Because I have a horizontal, I do not have a slant behavior. Again, I plug in 0 for x to find my y-intercept, and I have, what, -12/6, so that gives me a y-intercept at -2. And then my domain, I take into consideration my my vertical asymptotes, and that gives me this domain. And then on the range, it should be from negative, let's see, horizontal asymptote. Oh, yeah, my horizontal asymptote is at 3/2. And so my graph, when I graph this, it should look like this. And the horizontal asymptote right here affects the range. We good? Let's go back and look at that other one, this one here. All right, so we do say that this horizontal asymptote is at y = 0. However, this is wrong. It should just be from -∞ to +∞, because my graph does intersect the horizontal asymptote in the middle. Okay, so be careful with those. And then let's look at another one. What rational equation would create this graph? Well, first of all, you need to look at your x-intercepts and your removable discontinuity. So you have an x-intercept at -2. So in the numerator, you'd have x plus 2. And then in the denominator, you have a removable discontinuity. It looks like +2. So you would have this in the denominator and the numerator. Okay? And you also, it looks like you have a vertical asymptote there at 3. So we need to have x minus 3. And it also looks like we have a vertical asymptote right there at -3. So our factor would be x plus 3. Don't forget, when you're setting up your factors, you have to change your sign. All right, so that's what we have so far. Let's look at what the equation says. Okay, so, whoa, let's see, did we get everything? It looks like it, so we got everything. However, your multiple choice versions are going to be like this. Okay, so notice that I have everything, in fact, everything's foiled. So how do I know which one of those is the correct answer? Well, a couple ways I can check is I can actually graph those and see which looks like my graph. However, I will tell you hold on.
Please check your neighboring classrooms. If they are unattended, please call the front office.
My goodness, they have a lot of interruptions.
Check your neighboring classes.
Apparently a lot of teachers are late for school.
Please call the front office.
All right, back to the video. So we have these three options. I will tell you, of all of these, there's only one of them that would not give you a graph that looks like this. On your test, it's going to be different. But one way you can check is graphing each one and checking if they have the right functions. With your x plus 2 and x minus 2, you should have x squared minus 4. But if you look at each of these, they have a leading coefficient. So factor out that leading coefficient and see if you would have x squared plus 4 or minus 4. This one right here is the only one that would not give you the x squared minus 4 if you factor out the 2. Okay, so of all of these, every single one of these would work except for this one. Okay, this one doesn't work. Well, that's not what I wanted. There. So you have a multiple choice test. Go ahead and plug each of these graphs in until you find the one that best fits. All right, here we go. What is the diagonal and behavior asymptote for this function? Let me see how much time I have. I've got 5 minutes. I'll go over this really quickly. So if you have a question like this, you're going to have to do long division. And really, I'm going to show you all the answers. You just need to check. Just do long division. We know how to do that really quickly. Let's go through this. So we have to get 3x to become 6x cubed. I'm going to multiply by 2x squared. And I get this here. But I'm subtracting, so the signs change. I get 9x squared. And then I multiply by 3x. And then I get what's down here. And again, I'm subtracting, so my signs are changing. I get positive 6x. And let's see, I multiply by 2. And my remainder is down here. Remember, we don't care about the remainder. We just want what's up here. Okay? Hopefully, you remember how to do long division. If you don't, watch some videos. Here's another question. In this one, you're going to have slant behavior. Let's look at back at the other one. So this one, because this degree is 2 or more than this one, then you're going to have end behavior asymptote. This one will have slant behavior asymptote because your degree is just off by 1. And here is the long division for that. Again, do not forget to switch your signs, or you're subtracting down here. So always make sure you're changing your signs. All right, my class is coming in, so I got to get this finished up. I think this is the last one, which equation best fits the graph. Okay. Again, because you have a multiple choice test, you can plug each one of these in and see which one best fits the graph. I will tell you that just a shortcut, it looks like you have a vertical asymptote right there at -2. So look for something that would give a graph that would give you that x-axis or vertical asymptote, and that's the only one. Because you look at the vertical asymptote, you should have this x equals -2. And then again, you're going to have to do long division with this formula that you found up here to find the end behavior asymptote. Okay. Let's see. Yep, that's the end of the review. And my class is here, so I have to go ahead and get started. Please, if you need to watch this again, rewind it and watch it again. All right. Talk to you guys later. Bye.